Why is NASA planning for the end of the International Space Station? The International Space Station now has more than 23 years of a continuous human presence aboard the microgravity laboratory, with assembly missions starting in 1998. Throughout the years, NASA and its international partners have worked together to operate, maintain, and upgrade parts of station. The technical lifetime of the station is limited by the primary structure, which includes the modules, radiators, and truss structures. The lifetime of the primary structure is affected by dynamic loading, such as spacecraft dockings/undockings and orbital thermal cycling. NASA has committed to fully use and safely operate the space station through 2030, as the agency also works to enable and seamlessly transition to commercially owned and operated platforms in low Earth orbit. This will allow NASA to buy the services it needs from commercial companies for microgravity research and technology demonstrations, while the agency explores the Moon and Mars. Why did NASA decide to deorbit the space station instead of alternative options? NASA has examined several options for decommissioning of the International Space Station, including disassembly and return to Earth, boosting to a higher orbit, natural orbital decay with random reentry, and controlled targeted reentry to a remote ocean area. Disassembly and return to Earth. The space station is a unique artifact whose historical value cannot be overstated. NASA considered this when determining if any part of the station could be salvaged for historical preservation or technical analysis. The station's modules and truss structure were not designed to be easily disassembled in space. The space station covers an area about the size of a football field, with the initial assembly of the complex requiring 27 space shuttle flights, using the since-retired shuttle's large cargo bay, and multiple international partner missions, spanning 13 years and 161 extravehicular activities, EVAs, commonly known as spacewalks. Any disassembly effort to safely disconnect and return individual components, such as modules, would face significant logistical and financial challenges, requiring at least an equivalent number of EVAs by space station crew, extensive planning by ground support personnel, and a spacecraft with a capability similar to the Space Shuttle's large cargo bay, which does not currently exist. Though large modules are not feasible for return, NASA has engaged with the Smithsonian National Air and Space Museum and other organizations to develop a preservation plan for some smaller items from the space station. How will NASA deorbit the International Space Station? The primary objective during space station deorbit operations is the responsible re-entry of the space station's structure into an unpopulated area in the ocean. The chosen approach for safe decommissioning is a combination of natural orbital decay, intentionally lowering the altitude of the station likely using current propulsive elements, and then execution of a re-entry maneuver for final targeting and to control the debris footprint. Due to the high propellant requirement of this final maneuver, the Earth's natural atmospheric drag will be used as much as possible to lower station's altitude while setting up deorbit. Once all crew have safely returned to Earth, and after performing small maneuvers to line up the final target ground track and debris footprint over an uninhabited region of the ocean, space station operators will command a large re-entry burn, providing the final push to ensure safe atmospheric entry into the target footprint. What is the status of the Deorbit spacecraft? NASA announced SpaceX has been selected to develop and deliver the U.S. Deorbit vehicle that will provide the capability to deorbit the space station and ensure avoidance of risk to populated areas. What happens when the space station deorbits? Will parts of the space station burn up? The space station is by far the largest single structure ever built in space and represents physics and engineering challenges when it comes to re-entry modeling. The International Space Station is primarily made up of a combination of truss elements, modules, solar arrays, and radiators. The truss acts as the backbone of the station, providing physical support for the solar arrays, radiators, and modules. The various modules provide pressurized volume for the many microgravity experiments, a habitable area for crew, and ports for visiting spacecraft to dock and undock. The solar arrays and radiators provide power generation and thermal control for station hardware. Based on behavior observed during the re-entry of other large structures such as Mir and Skylab, NASA engineers expect breakup to occur as a sequence of 3 events: solar array and radiator separation first, followed by breakup and separation of intact modules and the truss segment, and finally individual module fragmentation and loss of structural integrity of the truss. As the debris continues to re-enter the atmosphere, the external skin of the modules is expected to melt away and expose internal hardware to rapid heating and melting. Most station hardware is expected to burn up or vaporize during the intense heating associated with atmospheric re-entry, whereas some denser or heat-resistant components like truss sections are expected to survive re-entry and splash down within an uninhabited region of the ocean. Are there any environmental hazards associated with bringing the space station back to Earth? The decommissioning plan for space station is the execution of a responsible, controlled, and targeted deorbit into a remote ocean area. During descent through the Earth's atmosphere, the space station would burn, break up, and vaporize into fragments of various sizes. Some fragments would likely survive the thermal stresses of re-entry. Environmental impacts of these fragments within the anticipated impact area are expected to be small. To best protect people and property on Earth, the most remote areas of the ocean are targeted. Once the debris enters the ocean, it is expected to settle to the ocean floor. Based on the findings of the International Space Station Environmental Impact Statement, no substantial long-term impacts are expected.